Alright guys, today we deal with our last main property with these properties of exponents. It's the power of a power property, which sounds super exciting with that word power everywhere. Just to recap, we know that if you have the same base and you multiply, you add the powers. If you have the same base, I'm going to jump over here. If you have the same base and you divide, you subtract the powers. A -1 is a reciprocal, but a negative a is a reciprocal with the power, so like x to the -8 becomes 1 over x to the 8th, and don't forget that like 2 to the -3 is 1 over 2 to the 3rd, which is 1 over 8. So don't make it negative. It's not -8 or -1/8. It's just 1 over 2 to the 3rd. Anything to the 0 power is 1. Those are our old properties we've been dealing with. We layer in one final one, which will kind of have some ripples that make it look like it's 2 or 3 or 4 final ones, but it's really just one. Now, believe it or not, all these properties we've been doing come down to this basic idea that we know how to count, right? Like, everything is just counting made more efficient, counting easier and faster. So like if I have x to the 3rd and x to the 5th, I could just count how many x's there are. There's 3 x's in the first case. There's 5 x's in the second case. Oh, there's 8 x's total. It's just counting. Instead of counting out 1, 2, 3, 4, 5, 6, 7, 8, we just add 3 and 5 because we know 3 plus 5 is 8. Adding is just faster counting. Multiplying is just faster adding. But everything with adding, subtracting, multiplying, dividing, it's mostly the idea of we know how to count, how can we do it faster, and how can we do it easier? Well, this last property is just another layer of counting, but it gets confused with the other ones, so we have to make a really clear distinction. This property we've done, it's when a base multiplies another base of the same sort, right? If x is our base, if 2 x's multiply, you add the powers. This one is different. This is a power of a power on one base. This has 2 bases, this just has 1. If I have x to the 3rd, to the 2nd, a power of a power, those powers multiply to become x to the 6th. That's our last property. It's called the power of a power property. It looks like this. X to the a to the b is x to the a times b. Not a plus b, but a times b. So don't confuse it with x to the a times x to the b, which becomes x to the a plus b. These are 2 incredibly important and foundational properties, but they are different. Don't start to confuse the 2. Now, we can see why this property works really easily. Again, it's just counting. X to the 3rd means this. All right, that's x to the 3rd squared. So x to the 3rd squared is just this. But squaring something means you multiply it by itself. So really we have 2 groups of 3. 2 groups of 3 makes 6. In the same way, if I had like x to the 5th to the 4th, well, sure. I mean, I could write out all those x's. Here's x to the 5th to the 4th, which means I have 5, 10, oh gosh, 15, 20. But see how I don't want to count out every time. I want the shortcuts. I want to think. Here's 5 groups of 4. 5 groups of 4 means we're multiplying. It's 20. So a power of a power becomes multiply. Let's do a bit more interesting examples now. We've kind of practiced this idea already. If you have -2 to the 3rd, we have to think about how that's -2 3 times, and that's actually -8. Whereas -2 to the 4th is +16, because you're adding on one more -2, you're multiplying by an additional negative, which makes it positive. If I had something like this, -2x to the 5th to the 3rd, well, I have to think about the fact that everything is being brought to the 3rd power. There's 3 of these -2x to the 5ths. So what it really becomes is -2 to the 3rd and x to the 5th to the 3rd. Right? Because there was 3 of these -2's multiplying, And there was 3 of these x to the 5ths multiplying. So it's going to be negative 8 times x to the 15th. And if I had like 4x squared y to the 3rd, all of this being squared. Well, that square is applying to everything right now. That would be 4x squared y to the 3rd times 4x squared y to the 3rd. That becomes 16x to the 4th y to the 6th. So here's how this property here, that's the main property, but we can kind of expand on it a little bit. If I have like x to the a, y to the b, and all of that is brought to the power of c, that becomes x to the ac, y to the bc. And all of a sudden we sound like rappers, right? Rappers don't do this very much anymore, but it used to be that to the was a very common phrase while rapping. Like, you young kids could look up this. H to the is O, V to the is A. You're too young for this, most of you at this point, but that's just classic Jay-Z right there. H to the is O, V to the is A. Well, this is x to the AC, y to the BC. The power on the outside applies to everything on the inside. So if I have an expression like this, 3x squared y to the 5th, and all this is being brought to the 4th power. I want you to write this out, thinking about how this 4 is going to distribute to each of these individual pieces. 3 to the 4th, x to the 8th, y to the 20th. Every single piece there got that power of 4 applied to it. 3 to the 4th is 81, so it's 81 x to the 8th, y to the 20th. Okay, last one we'll do here, and then we'll call it a day. Let's go with a nice little green. If I had a fraction brought to a power, that power is going to apply to the top and to the bottom of each piece. So we have x to the 8th over y to the 12th. And so if I had something like 2a to the 3rd over 5b to the 4th, and all of that was brought to the 6th power. Well, I shouldn't have done 6 because 5 to the 6 is going to be a pretty big number. But what I would do is 2 to the 6 times a to the 3 times 6 over 5 to the 6 times b to the 4 times 6. Every single thing is brought to the 6th power, which is going to become 2 to the 6 is 2, 4, 8, 16, 32, 64. I'm actually counting on my fingers, just so you know. 5 to the 6 is 5, 25, 125, 625, 3125. 64 over 3125 with an a to the 18 and a b to the 24. It's kind of a cool fact here that this fraction can definitely not reduce because these had nothing in common. Since the 2 and the 5 can't reduce, the 64 and the 3125 can't reduce. It's kind of nice. So our final properties look like this. X to the a to the b becomes x to the ab. If you have multiple things, the power distributes to both of them. If you have if you have a fraction, the power distributes to the top and the bottom. But really, these two properties are just extensions of this one. Like, we could boil all of our properties down into these ones. X to the a times x to the b equals x to the a plus b. That is a fundamental property from which other properties come. I could even argue that this one is not a fundamental one, but comes from another one, but I'll keep it. X to the a divided by x to the b equals x to the a minus b. 2 more. X to the negative a equals 1 over x to the a, which I could even argue just comes from this, because it really does. And finally, x to the a to the b is x to the a times b. These are basically our 4 fundamental properties. If those are the only 4 things you learned in this chapter, but you can apply them correctly and consistently, you're going to be fine for every type of problem we see. All right, thanks for watching. See you next time.